In the first round of a robotics engineering challenge, a team must earn at least 70% of the maximum possible points to qualify for the international stage. So the team must earn at least 70%. All right. So it can lose maximum 30%. Fine. After the first round of scoring, the team had earned exactly X points, while the remaining Y points were lost due to errors. So the team had earned X and lost Y. So total points were X plus Y. Yeah. Total possible points were X plus Y. Does that make sense? Yeah. Because then it got X and it lost the rest of the Y points out of the maximum points that it could have got. Fine. Now, the lead engineer correctly concluded that the team did not qualify based on this score. What does this tell me that the team did not qualify? It tells me that this X is not 70% of the total X plus Y. Yeah, it is less than 70%. They would have qualified in case this X and Y was in the ratio of 7:3. Am I okay with that? Yeah. But definitely the ratio is less than 7/3, yeah, of X and Y. Okay. However, if the team had avoided just one of the lost point errors, their score would have increased enough to qualify. So now they're saying that they got X and they lost Y, but in case they had, got just one of the, they had got like just one of the lost points. So instead, if I pick up 1 point from here and give it to X, then they would have qualified, which means that my Y minus 1 and my X plus 1, I know that my this ratio is less, right? My X by Y is less than 7/3. Is that okay? Yeah. But if I just pick 1 point from Y and give it to X, then my X plus 1 upon Y minus 1 is definitely more than 7/3 or equal to 7/3. Either ways, they qualify in case it is 7/3 or more. Is this okay? Any doubts over here? Yeah, of course, we're not going to do all the algebra, and we're not even going to, we don't really need to write this down neither, but just for your understanding, I'm writing it over here. The only thing that I have to think about here is that X by Y is certainly less than 7/3, but X plus 1 upon Y minus 1 is more than 7/3 or equal to 7/3. All right. Okay, so then their score would have increased enough to qualify, assuming everything else remains the same. Select a value for X and a value for Y that are jointly consistent with the information provided. Make only two selections. So now, look, you see that I have variables that I don't have enough information to get the actual values of X and Y, right? I don't know how I'm going to solve it. I just know that this is less than 7/3. This is greater than, this is too complicated. I don't really know how to start solving it. What do I do? Look, just like in quant, we always keep the options in mind, right? Our one eye is always on the options. Similarly, in your TP also, for that matter, even in our graphs, I told you that the first thing you do is you click on that drop down, right? Because those are the options that are available. Similarly, in your TPA also, the available options are going to reduce the universe of what is possible substantially. So I have to keep an eye on what is given to me. What are the possible values of X and Y? Now, both X and Y, or both two variables are taken from the same set of values. If they have a relation between them, it further reduces my universe a lot. Like, for example, what do I mean by that? I know that my X by Y is less than 7/3, but I certainly know that X is quite large as compared to Y, right? Because by just removing 1 from Y and giving that to X, it became in the ratio 7:3 or even more, right? So I know for sure that X is going to take one of the larger values. So perhaps, one of these kind of values, and Y will take one of the smaller values, right? Okay, now let me take a look at this. Look, my Y is 3. This is the ratio 7:3, where the change happens. If my Y is 3, my X is 7. Now, again, go back to what we've been discussing for the past few weeks, how to compare fractions, how to compare ratios, right? What is this? 7. 7 is double of 3 and then some, right? And one more. What is this? 1. 1 is your 1/3 of 3. That is 33% more. So to go from 3 to 7, what do I need to do? I have to double it, and then I have to add another 33% to it, right? That is my ratio essentially. Yeah, that is what I'm getting. All right. So now let me look at 12. When I say 12, if my y were 12, as I said, the given option is extremely important. If my y were 12, what would my x be? If I say it has to be very close to, 7 is to 3, right? If my y were 12, my x would be double of y and then another third of y, which means that it would be 24 plus another third, which is 4, right? So a 28 will give me an exact ratio of 7 is to 3. I do have a 28. Does it mean this is the answer? But x by y, the ratio is less than 7 by 3, which means that this cannot be the answer. Because if x were 28 and y were 12, then, at least 70%. I would have got 70% and they would have qualified in that case. But I know they did not qualify, which means that the ratio is certainly less than 7 by 3. And a 28 and 12 gives me a ratio of 7 by 3. So that is not okay. All right. Now, this is 7 by 3. When I look at 12 and 32 or 12 and 36, these are becoming really large ratios, right? Because 12 by 28 is exactly 7 by 3, isn't it, right? So then they can certainly, anyway, they're becoming greater than 7 by 3 if I look at 32 and 36. So those are not possible because my x by y has to be less than 7 by 3. Yeah. All right. Then 24 is anyway twice. So that doesn't work either. All right. So I know that my 12 is not going to work. Look at 16. If my y were 16, what would x be so that the ratio is exactly 7 is to 3? What do? I double my 16, so I get a 32, plus I add another 1/3. A 1/3 of this is a little more than 5. I'll just approximate. I'll say, a little more than 37. Yeah, that would give me a ratio of, so let's say 37 point something upon 16 is going to give me a ratio of 7 by 3. Okay, so with 16, I do have a 32, which is twice, which is not enough, but I have a 36 over here. So with a 36 by 16, I know that my ratio, this is going to be less than 7 by 3. All right, and slightly less than 7 by 3, so very promising. Now, let me check. I say that in case 1 point was taken away from 16, so if 16 became 15 and it was given to your 36, so if this became 37, would my ratio, this ratio, be greater than 7 by 3? Again, what do I have to do? I double my 15, which means I get a 30, and I add another 1/3 to it, which means another 5. So I get a 35 in this case. This is more than 35, which means this ratio is more than 7 by 3. And that is why my answer is going to be 16 and 36. Right? Look at the other. Okay, I may not even actually need to check for 16 and 36 because, as I said, I'm looking at the other options as well. And I see 24, 28, 32. These cannot be, none of them can be the value of y, right? Because I don't even have there twice. I mean, I don't have a 48 and I need something more than there twice to have that ratio of 7 is to 3. So then I know that all these values cannot be the value of y. I saw 12 cannot be, which means that 16 has to be. Then because the value of x has to be more than double of 16, which means the only possible value is 36. And that is why I get my answer as 36 and 16. Does this make sense? Guys, it's very important. So, when we keep saying that ratios are important, percentages are important, weighted averages are important, it's not essential that they'll give you a ratios question directly, that or a percentages question directly. Like everything is not going to be all based on, let's say, profit loss or simple interest, compound interest. these are the ways in which my percentage is important. So when I'm looking at this ratio of 7:3, percentages are handy, because to establish the relation in this 7:3, how do I say that when my number is 3, then what is 7? 7 is twice of 3, that is increased by 100%, and then it increases by another one third because it increases by 1, which is one third of 3. So another 33% increase, right? So my 7 is essentially 133.33% more than 3. Yeah. And if you were able to do that relational analysis between the numbers, then calculations involved are nothing. Look, think about it. It's all oral in that case, right? I don't have to calculate anything in that case. I'm just saying, okay, 12. Then I'm looking at 24 plus a 4, that means 28. 28 will be exact 7 by 3. I have a 28, which means 24 is going to be too small and 32 is going to be too large, of course. Right? And that's it. I'm done there. Right? And figure out the relation, when especially when X and Y have some kind of a relation between them. Then even though you have these many values available to you, there'll be a smaller set which is going to be applicable for X, and a smaller set which is going to be applicable for Y, right? I see over here that X is going to be much larger than Y. So I'm going to find my X somewhere over here, and I'm going to find my Y somewhere over here, which means that if I'm going to check, I'll start with the smaller values for Y. I'm obviously not going to start with the larger, right?